Students will be able to graph parametric equations. Sketch the curve represented by the parametric equations, indicate the orientation of the curve, and write the corresponding rectangular equation by eliminating the parameter. On this particular problem, we're going to use integers from -2 to 2. So we'll have values for the parameter t. That's going to be the -2, -1, 0, 1, and 2. We'll have x values, and we're also going to have y values. So let's plug these t values in for this t to get the x values. So that'd be -8, -1, 0, 1, and 8. Now we're going to plug the t values in for the t over here to get the y values. So 4 divided by 2 is 2. 1 divided by 2 is 1/2. 0 in there is going to be 0. And then 1/2 and 4 divided by 2 is 2. Now, once we've plugged in the t's, we don't need those anymore. We're going to plot the point -8, 2. 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, and 8, -8, 2. -1 is 1/2, 0, 0, 1, 1/2, 2, 3, 4, 5, 6, 7, 8. Now, when we graph these, they have a beginning and an end. And if we were to graph all of the points, not only does it have a beginning and end, we also have a direction. So the direction is this way. And that's where we're doing the orientation of the curve. So we're graphing this way. We just make a few arrows along the curve to indicate which direction we went. Now, this last piece is asking for the Cartesian equation. In other words, y equals something, or x equals something with, like y equals something with x equals something with y. Well, we have to get rid of the parameter, got to get rid of t. How about we just take the third root of both sides there? So we're going to go third root of x is equal to t. Now we're going to plug that in for this t over here. So we get y is equal to the third root of x squared, because that's the t squared, and then over 2. So that's squared. Same instructions with a different graph, but now in this particular case, we're not going to go from -2 to 2. We're going to use nice values for t. And nice values means I'm going to plug t values in here that doesn't cause decimals. So how about 0, 1, 4, 9. How about we go all the way? Should we all, we'll stop before 16 because x values, if we go by ones, we can only get to 10, I think. So let's plug in t's to get x's. That's going to be the 0, 1, 2, 3, and 4. Actually, we could go farther because I was thinking x values, but these are the t values. So we could go 25, and that's 5. We could go 36, and that's 6. But we're going to get some really big numbers when we plug t's in here. So it's really the y that's going to kind of dictate how far we go with this. So 0 minus 2 is -2. 1, oh, that should be a 1 there. 1 minus 2 is -1. 16 minus 2 is 14. 81 minus 2 is 79. And that's probably how far I would take it right there using this graph. So we'll have to let's go by tens. So we have, now once we get the t values, we're not going to use that to plot anything. Now we're going to plot the x's and y's. So 0, -2, maybe that's there. 1, -1, a little higher up. 2 goes to 14. So 2 goes to 14. And 3 goes all the way up to 79, 20, 30, 40, 50, 60, 70, 80, right there. And so maybe about right there. And so we have this is actually a parabola. Like this. All right, there we go. But now we have to write the Cartesian. Instead of writing it down here, I'm going to write it up here where I have some room. You can write it down there if you want, if you're following along on this. We got to get rid of the t. How about we square both sides here and we get t is equal to x squared. Now we can put that into, I guess this wasn't a parabola. Y is equal to x to the 4th because it's x squared and then -2. But now x has the possibility of being negative for this, but on the original equation, there's no way x is going to be negative. So we have to say x is greater than, now can x be 2? Well, x can be 0 here. So greater than or equal to 0. This graph ends up being the unit circle. So since we have trig, we have x as cosine t and y as sine. That's exactly what the unit circle is. We have our t values. How about we do go 0, pi over 2, pi, and 3 pi over 2. So if we plug 0 in, cosine of 0 is 1. So on the x values, it'd be 1. And then cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is back to 0. I guess we could go all the way to 2 pi, and that's back to 1. So the y values is 0. Sine of pi over 2 is 1, 0, -1, and 0. So we're starting over here at 1. Should we just make it, I guess, make it real tiny like that? Got 1, 0, 0, 1, -1, 0, 0, -1, and back to 1, 0. So we have a beginning and an end. And we have an orientation. So it's like this, around in a counterclockwise direction. Now, if we want to get rid of, if we want to write the Cartesian equation for a circle, we know that cosine squared t plus sine squared t is equal to 1. So that means we have x squared plus y squared is equal to 1. And that's the Cartesian equation of a circle. The parametric equation for a circle, you have to use trig. Now, in exercises 3 through 20, sketch the curve represented by the parametric equations, indicate the orientation of the curve, and write the corresponding rectangular equation by eliminating the parameter. Same thing, right? So this graph stretches x and y by 3. So you multiply each by 3. So x is cosine, y is sine. So then we're going to go 3, 0, 0, 3, -3, 0, and 0, -3, and then back to the beginning. So this is the unit circle also because x is cosine, y is sine. I'm trying to draw a circle here best I can. And then now we want to get rid of the Cartesian equation. We could write x over 3 is equal to cosine of theta, and we could write y over 3 is equal to sine of theta by using these two equations here. And same thing, cosine squared plus sine squared equals 1. So x squared over 9 plus y squared over 9 is equal to 1. But we don't leave circles like this. We write x squared plus y squared is equal to 9. So x squared plus y squared is equal, this is actually the radius squared, and the radius is 3. We have one down here. And I said, let's graph these -2 to 2. So t, -2, -1, 0, 1, and 2. So the x. Let's see, we got to plug -2 in. 4 minus 4, that's 0. 1 minus 2 is -1. 0 plus 0 is 0. 1 plus 2 is 3. And 4 plus 4 is 8. So let's get the y values, and we got to remember we're plugging in the t's, not the x's. So let's plug in -2. 4, was that 4 plus 2? That's going to be 6. 1 plus 1 is 2. Plug 0 in. That's going to be 0 also. 1 minus 1 is 0. And 4 minus 2 is 2. So we have to plot. Let's get rid of these so we don't look at these to graph them. 0, 6, 1, 2, 3, 4, 5. So that's up here. 1, 2, 3, 4, 5, 6, 0, 6. -1, 2. 0, 0. 1, 2, 3, 0. And 4, 5, 6, 7, 8, 2. So it does something like this. And like that. So we have a beginning and an end. And this is the direction that it graphs, like that. All right, and we got to eliminate the parameter on this one. To do that, we have to complete the square on one of these. So we'd have y plus, should we do, let's see, we can't complete, I don't want to complete the square on that because b squared over 2 would be a half. How about we do it on this one? So x equals t squared plus 2t plus 1 minus 1. So x is equal to, that'd be t plus 1 times t plus 1, or t plus 1 squared minus 1. So we have x plus 1 is equal to t plus 1 squared. And then, let's see, we would have the square root of x plus 1 is equal to t plus 1. And so t is equal to negative 1 plus square root of x plus 1. But now we got to plug that in for these t's right here. So how about negative 1 plus square root of x plus 1, like that. And then minus negative 1 plus square root of x plus 1. What if we have x equals 5 cosine, which is the same as the unit circle, but then this is going to make this an ellipse because y is sine. So this graph stretches the x by 5 and the y by 3, creating an ellipse. So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. And 1, 2, 3. And you can still make a chart. Go theta, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and plug in all the values. But this is what you're going to get. It actually starts over here. So we have this ellipse. That. And also, again, in a counterclockwise direction, just like we do with the unit circle. Now, if they make x as sine, and y as cosine, then we're probably going to have to get some values and figure out what's going on. So just like this, speak of the devil, here we go. Theta, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So now if we go x, sine of 0 is 0, pi over 2 is 1, so that's 3. Sine of pi is 0, 3 pi over 2 is negative 1, so that's negative 3, and then we're back to 0. With the y values, cosine of 0, cosine of this 0 is 1, so 5, 0, negative 5, 0, and back to 5. So let's change some color here. Now it starts up here, 1, 2, 3, 4, 5, up there. Then we go to 3, then we go to negative 5, and to 3, and then back up to the top. So it's still an ellipse, but because it's not exactly what the unit circle is, it's not gonna graph the same. It's gonna be same direction in this case, but it's gonna be an ellipse, and it's starting up at the top and not over here at 0 degrees where we usually start. How about, how about getting rid of, how about writing some equations here? Well, now we have x over 5 is equal to cosine theta, and y over 3 is equal to sine theta. Now these are ellipses, so we have x squared over 25 plus y squared over 9 is equal to 1. And with ellipses, we do leave it like this. We don't leave it like this with circles. So this would be x squared over 9 plus y squared over 25 is equal to 1. Sketch the curve represented by the parametric equations, all that good stuff. X is cosine, y is sine. There's no negatives. There's nothing strange. 1, 2, 3, or no, 2 this way. And then 1, 2, 3, 4. 2 this way. 1, 2, 3, 4 down here. And it does start over here at 0 degrees. And now we have this ellipse. And it does, it goes in counterclockwise direction. Like that. So the Cartesian equation would be x squared over 4 plus y squared over 16 is equal to 1. Let's graph this from -3 to 3. So 9 minus 2 is 7. 4 minus 2 is 2. 1 minus 2 is -1. Then we have -2. 1 minus 2 is -1. 2 minus 2 is 4 minus 2 is 2. 9 minus 2 is 7. There we go. We got -9, -6, -3, 0, 3, 6, and 9. And we'll plot these. 7, -9, 2, -6, -1, -3, -2, 0, -1, 3, 2, 6, and 7, 9. And we have this parabola, and we're graphing the parabola from the bottom to the top. That's the direction that we're going. We have a beginning and an end, so we'll say what direction it's going. This way. And then having x instead of y, having x equals instead of y equals is certainly okay. Well, I guess that's not necessarily for this one, but it doesn't really ask us to get that to Cartesian. So if we're given this right here, this example, I don't really know how I would get t by itself with the x. So it's okay to solve for t here. Y plus 2 is equal to 3t. So t is equal to y plus 2 over 3. And it's perfectly okay to go y plus 2 over 3 minus 1, absolute value, and have it as x equals instead of y equals. That's still a Cartesian equation. Some of the Pythagorean identities, sine squared plus cosine squared equals 1. If you divide this by cosine squared, you get tangent 1, and 1 over cosine squared is secant squared. If you divide this by sine squared, this is the 1. Cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant squared. So those are your Pythagorean identities as a little reminder.